Okay, his answers to the second one. So differentiate 2 sine 3x at 1. Well, sine goes to cos, but I then need a times by the derivative of the function inside. So I need times by 3. 2 times 3 is 6. So it's 6 cos 3x plus 1. Differentiate ex squared minus 7. Well, e differentiates to e, but I need times by the derivative of the function. Yeah, remember the secret brackets around that. So differentiate x squared minus 7 gives me 2x. And last one, differentiate ln 8x plus 3. Well, ln differentiates to 1 over, so 1 over x plus 3, but I need times by the derivative of that function, so 8x plus 3 differentiates to 8, so times by 8, I just give an 8 in the top there. Okay, second one, still some more differentiation. So y is 3x add 2 to the power 9, and we want the normal when x equals minus 1. So straight away, sub in minus 1 into there. So 3 times minus 1 is minus 3, plus 2 is minus 1, power of 9 is minus 1. So I've got my coordinate. Now I need the gradient, so I need to differentiate. So the rule for bracket, remember, I times by the power, take away 1 from the power, but I need a times by the derivative of this function. So 3x plus 1 differentiates to 3, times by 3, so 27, 3x plus 2 power 8. Sub in x is minus 1, and I get dy by dx. Well, that gives me minus 1, power 8 gives me positive 1 times 27, it's 27. Since it's normal, I need to do the negative reciprocal. So minus 1 over 27, then use y minus y1 equals m x minus x1, and rearrange it how you like. So you could write it as that, or you could times up by the 27, expand by the minus 1, and take everything to one side, x plus 27y plus 28 is 0. That's how I would write it. Okay, third one. We have 4 cosec squared theta minus 9 equals cot theta. Okay, so don't change things in the sines and coses just yet. Just think, I've got cosec and cot and 1 squared, so I can use our new formula. 1 plus cot squared theta is cosec squared theta. If I just rearrange that to get, actually I don't need to rearrange, I've got cosec squared by itself ready. So I just need to sub into there, so I need to times all this by 4. So 4 lots of 1 plus cot squared theta minus 9 equals cot theta. So 4 plus 4 cot squared theta minus 9 is cot theta. Take everything to one side, make it quadratic. Now again, this could be y, so this is y squared, so y is cot theta. So I get 4y squared, take away y, take away 5, 0. Just take in your calculator. So 4 minus 1 minus 5, or factorize it. I get y is 5 over 4, or y is minus 1. Sub back in what y is. So cot theta is 5 over 4, or cot theta is minus 1. Now we need it into tan. So tan theta, I flip it, remember, 4 over 5, or tan theta, flip minus 1, just get minus 1. And then solve them. So I'm running out of space, so I'm just going to show you my calculator. So you do tan minus 1 of 4 over 5, so arctan 4 over 5, get the first angle, 38.7. Then you would add 180 to it, so 218.7. And then arctan minus 1, gives you minus 45, which isn't in the range. And I add 180 to it to get my second answer. So 135, that is in the range. And then I can add 360 to that first one, which gives me 315 degrees, so 4 answers. Okay, fourth one. I'll put this one on again until we can master sequences. Just a little bit of lighting. It's probably too much light now. So we've got the recursive sequence un plus 1 equals un plus 3, and the first term is 1. So first thing to do, work out the first few terms always. So u2 is u1 add 3. So 1 add 3 is 4. u3 is u2 add 3. So 4 add 3 is 7. So the sequence goes 1, 4, 7. So if we can spot a pattern, it's just arithmetic. Yeah, I'm just adding on 3 each time. So A is 1, D is 3, and we want this sum from 1 to 50. So N is 50, and now since it's arithmetic, we can use that SN formula. That you get given. So sub everything into there. So 50 over 2 times 2 times 1 plus 50 take away 1 times 3. Type that on your calculator. 2 add 49 times 3. 3,725. Yeah, remember you can check this one on your calculator because you can work on M10 for this one. And the last one, so pulleys. I'll try and make it a bit trickier. So we're getting good at this. So there's air, and we know that there's 2 kilograms. There's B, and we know B is M kilograms, but M is less than 2 because this one's heavier. So put the weights on, put the tensions on, and we also know that the acceleration is 1.2. This one's going to go down by 1.2, this one's going to go up by 1.2. So get your 2 equations. So for air, it's going to go down, so 2g minus t is 2 times air, which is 2.4. Then for B, T minus mg equals m times air. Remember, air is 1.2, that's just 1.2m. So I can do the same things before, I can add both equations so that the t's cancel out. So I've got 2g take away mg, because 2g plus minus mg, plus and a minus makes a minus. On this side, I've got 2.4 plus 1.2m. So now it's just an equation. I can rearrange it to get the n's on one side. I can take the mg to this side, so mg plus 1.2m. Take away the 2.4 to that side, 2g take away 2.4. Factorize out the m, g plus 1.2, and this side 2g take away 2.4, and then just divide by it. So 2 times 9.8, take away 2.4, divide by 9.8 plus 1.2. So I get m equals 1.56, but blah. Since I've used g is 9.8, I need 2 significant figures, so 1.6 kilograms, and just double check your answer makes sense. It does, because we wanted m to be less than 2, didn't we? We wanted this to go down.